All right, welcome to Driven Math and Physics. Today we're going to continue looking at Archimedes principle problems. And so the problem that we're given here is a block of mass of 500 grams. So we know that the mass of this block is 500 grams. And then we also have the volume of the block, which is 4 times 10 to the power negative 5 cubic meters. Okay, and it is in a liquid of density 1000. So density of the liquid is 1000. This is water we're dealing with. Okay, now when you look at the questions that I want us to do, number one, they want us to calculate the apparent weight of the block. Okay, that is the weight of the block in a liquid. Normally that's what it would mean. Finding the reading on the spring balance supporting the block. So when the block is immersed, find the reading on the spring balance. Now this right here shows us that actually they're asking for the same thing. So what we're going to assume is that maybe the first question was simply an error and they wanted us to find the upthrust, which is the apparent loss in weight. Okay, and this one will be the weight of the liquid, weight of the block in the liquid. Okay, that's what we're going to do there. So let's get started. How do we find upthrust? What we know is upthrust is equal to weight of the liquid displaced. And the weight of the liquid displaced is equal to density of the liquid times volume of liquid displaced times gravitational field strength. Okay, so the upthrust will be equal to density of the liquid is 1000, okay, kgs per cubic meter multiplied by the volume of the liquid displaced. We assumed that this thing was fully immersed because I didn't specify in the question. Without that, it will be impossible to solve it. So from there, if we assume that, it means that the volume of the liquid displaced will be the same as the volume of the block. Okay, so that will be 4 times 10 to the power negative 5 cubic meters multiplied by 10 newtons per kg gravitational field strength. Okay, so these things cancel out. We remain with the newtons, and the upthrust now will be equal to 0.4 newtons. Okay, now that's part A. Part B, they want us to find weight of the block in the liquid. This one will be equal to weight of the block in air minus upthrust. So the weight of the block in air, we can calculate it. If we convert the mass of the block, it will be 500. We're converting into kgs. It will be like that. This will be equal to 0.5 kgs. So it will be 0.5 converted now to the weight of the block in air. So weight of the block in air will be equal to mass of the block times gravitational field strength, which will be equal to 0.5 kgs multiplied by 10 newtons per kg. The answer that we get is 5 newtons. So it will be 5 newtons minus 0.4 newtons. You get 4.6 newtons right here. Okay, now the question is in part C that if the liquid is replaced with another liquid of density 900 kg per cubic meter, what will the new reading be? So if we actually replaced the liquid here, instead of 1000, instead of using water, we use a liquid of density 900, what would happen? Okay, so let's try to do that right here. So part C, what will be the new reading? It means we need to calculate this thing again. So we need to find the upthrust. So the upthrust will be equal to 900 kg cubic meter multiplied by 4 times 10 to the power negative 5 cubic meter multiplied by 10 newtons per kg. Let me punch this into my calculator, then try to find the answer from there. Let me try to find the answer from there. So it is 900 multiplied by 4, okay, times 10 to the power negative 5, okay, and then multiplied by 10. That gives us 0.36 newtons. Okay, so that's 0.36 newtons. And then from there, what we're going to do is we're going to find the weight of the block in the liquid again. That's weight in air minus upthrust. That gives us 5 newtons minus 0.36 newtons. Okay, so what we end up having is 4.64 newtons. That will be the new reading of the spring balance. Okay, that will be the new reading of the spring balance. So does this really reflect what we think would happen if you place this object in a liquid of high density, which is water, as 1000? We're getting an upthrust of 0.4. When you place it in a liquid of a lesser density, what ends up happening? The upthrust decreases. Does that make sense? I think it makes sense. So that's what we end up expecting. So this is all I had for you today. Give me your thoughts in the comment section. Thank you.